Everyone, welcome to the iRobot Automation YouTube channel. In this video we are going to discuss how to address the input and output in Indra Works Engineering or Indralogic directly. So let us see how it can be done. So in the previous video I mentioned like how to create a shortcut for Indralogic. Please refer that. So you have to click on the Indralogic shortcut and you have to create a project here. Go to File, New. The top down menu, you have to select the type of PLC, L2003 version. Click on OK. Then LD programming. So here, once you open the file, means you have created the project, right? So and after that your programming language should be in ladder logic. Make sure that if it is not there, then you have to change it. Okay, since we have selected LD program, it will be there. In the these are the commands actually. So you can see normally contact, normally open contact is there, and this normally close contact is there, and this is how to add a normally open contact parallel, normally close contact parallel, set coil, set coil, reset coil, then function blocks you can take it. So these are the things we can discuss one by one, but this video is about how to address the inputs and output, right? So this is important. In Bosch Rexroth PLC, inputs, that is digital inputs, DI is addressing is done by syntax. This is a syntax. Percentage IX, I means input, Q means output, percentage IX, then 0.0. 0.0 means, say for example, it is like nothing but a byte number. First zero is nothing but byte number. This is a byte number, this is a byte number, and this is a bit number. Okay, if you take the zeroth byte, there will be 8 bits, right? So this is third one, fourth one, fifth one, sixth one, seventh, and eighth. So this is actually byte number 0, byte number 0 and bit number 0. Okay, so in 1 byte 8 bits will be there. So what is the last number? What is the input address for the 8th input? That is 0.7. What is the address for the 5th input? That is 0.4. Correct? So like that you have to do addressing. Say for example it can start with 1.0, that means byte number is 1. So 1.0 if you started, then last number is 1.7. Like that it should be addressed. Okay, same thing it also follows for digital output. And there is another variable like markers, which are regularly used in HMI and SCADA. It's a system variable. It's also called markers and internal relay. It's a bit memory. If it is, it can be used as a digital input as well as output. Both are there possible. That is system memory, so you can use it as an input as well as output. So syntax is percentage MX 0.0 or 1.0, like that you can take up. Okay, there is no limitation on markers or internal relay. Any number you can use it, but when it comes to the hardware, that is real input and real output. So that is having a limitation. How many inputs that PLC has got? What is the type of the PLC, and how many extensions is there? That is also important. Okay. So with this, let us go to the input. Say for example, I'm zooming it. So I'll take normally open contact this, and this is the input, and click on the network. Click on the network and then select coil. You can also add network. Say for example, this is network after. Network after means after line number 1, again one more network you can create, or before network also option there, you can create it. or network, or also a technical word called rung. Okay, this is a rung. Now input, how to add it? You can directly type here percentage ix 0.0. That means input number 1. This is output number 1 means percentage qx 0.0. Okay, but see what happens here, it's very difficult to remember what it actually meaning. For example, whether it's a start button or stop button, so when more number of inputs and outputs are there, it is difficult to understand with this type of declaration. So in that case, you can create the variable by name also. That means, say for example, this is a start button, type start and then enter. In the address location, you have to type the address percentage ix 0.0. That means start switch or something, it is connected to input number 1, that is percentage ix 0.0. Okay, and output also you can call it as, for example, LED, enter. Then in the output section you have to type the address percentage qx 0.0. okay, so this is how you can mention the address. And the marker means, say for example, I'll take the same input, so you can drag and drop once address is declared, and address is case sensitive. The start button starts with capital letter is different, start button starts with small letter, that is different. Okay, so that is why you can drag and drop here the address. And output, you can also use the memory means bit memory function or a system memory function, internal variable or internal relay. Say for example, they say it's a marker or motor, say, but you can type percentage mx 0.0. that means it is not physical input and output, but it's a output, but it's valid only in the system. Okay, we use it in HMI and SCADA applications more, because we need a internal variable where we can operate it as an input as an output to exchange the data between the devices. Okay, in that case it is useful. So this is how you can addressing the inputs and outputs. Say for example, if you want to change the, for example, you want to change start button to second input. Okay, that means percentage ix 0.1. So how can I change it? Already declared, but how can I change it? Shift F2 is the button. Shift F2. Shift F2. 1 minute. Shift F2. Then you will get another, means there you will get a window, so you can edit a program here. Say percentage x 0.1 I want address, you can, so it will be updated here. Okay, don't try to edit directly here. If there is a syntax problem, then you will get an error where you have to do entirely new program once again. Okay, this is what declaring input and output. Okay, we'll how to simulate the program, so we'll discuss in the next video. Thank you everyone. Subscribe to my channel. Thank you.